In this example, we're going to see a Riemann sum in action. We're going to use a Riemann sum to approximate the definite integral from 0 to 4 of 3x squared plus 2. But I want you to forget that. Let's pretend we don't know what this function is, and we're just going to call it f of x. Let's pretend we don't know the equation for it. What we do know are some select y values. So we can use the left and right and sort of the midpoint sum. You can use the table to find those y values. So let's do the left sum first. Remember, the idea of a Riemann sum is we're going to find the sum of a bunch of y values times a bunch of x distances. And we're going to do that starting with the first rectangle. And let's just keep it simple here, and let's use 2 rectangles. So if I want to use 2 rectangles, or 2 subintervals, to approximate the Riemann sum here, to approximate the definite integral, make things easier, I'm going to chop this in half. I'm going to use that as my breaking point. So the left sum, I would use the leftmost point from the first interval to find the y value and multiply that by the x distance to find the left sum. So that first product would be the y value when x is 0, because 0 is all the way on the left, times the x distance, which in this case is 2. And I can plug in f of 0. I can use the number that they gave me for f of 0 and say that this rectangle, the area of that rectangle, or the product of y times x distance, is 2 times 2. And then I'm going to add to that the next product of a y value times an x distance. And again, I'm going to use the leftmost x value from within that interval to find the y value that I'm going to use to build a product. So it's going to be the y value when x is 2 times the x distance, which again is 2. And this time, the y value we'll use is 14. So this is 4 plus 28, which is 32. So my left sum is that this definite integral is 32. I'm just going to move this over so that I have room to do my right sum also. I'll do my right sum on the next space, red. Similar idea, I'm going to take my interval from 0 to 4, chop it up in half, so I'm just going to only use 2 products to keep the calculation simple. But this time, I'm going to use, for my first rectangle, I'm going to use the rightmost x value, which is 2, in order to find the y value to build my first rectangle. So it's still an approximation for the same thing. The sum of my 2 rectangles of the y value times the x distance. But this time my first y value is going to be the 14, because that's the y value here. And my second y value, I will choose the rightmost x value in the interval, the subinterval, to find the y value to multiply by the x distance, make the product. So the y value I chose is f of 4 this time, and the x distance is still 2. And that's 128. So notice these two are very different from each other. Because this function is increasing the whole time, the left sum is always going to underestimate because in this particular instance, if you only choose the leftmost point, of course, that's going to be the smallest possible y value you could have chosen, so it'll underestimate the truth. And the right sum will be choosing the biggest y value from each interval, so it'll definitely be an overestimate. If I wanted to do a midpoint sum, it's the same idea. The sum, I'm only using two rectangles again, of some y value times some x distance, and we just need to use the middle of each interval in order to find the y value. So I'm going to use the middle of my first interval to find the y value. So I'm going to need f of 1. I'm going to multiply that times the x distance. And I'm going to add to that, and that'll make my first rectangle, my first product. And then for the second subinterval from 2 to 4, I'm going to use the middle again, which is 3, to find the y value, and multiply by the x distance. So I'll need f of 3 times 2, which in this case f of 1 is 5, and f of 3 is 29. So that's 10 and 58, which is 68. Just for fun, we can compare that to the actual definite integral. Because remember, the function itself was 3x squared plus 2. So I can graph that. I don't really need to graph it. And then I can find the definite integral from 0 to 4 of f of x in respect to x, and it is 72. So you can see that 68 was actually pretty close.